Okay, welcome back. Let's finish up our module talking about port mirroring. Another feature where if you need it, it's available in our virtual network, but it may not be something that everybody's using all the time, right? It's basically if you've got a need to do some kind of actual network analyzer, right? Running some kind of Wireshark analysis of a VM's traffic, well, we can capture that. Now, you can do something like this on a standard switch, but it's quite a bit of a difference there. Let's take a look. With a standard switch, what do you have available to doing some kind of network analysis? You have to have a port group set in promiscuous mode, which basically grants every VM on the port group visibility across the entire virtual switch. That basically means that it's a port mirror for everything it's in that port group. Or if instead you set promiscuous mode on the entire virtual switch, that means every port is a port mirror to everybody on that switch. That's not a lot of granularity there, right? That is the most coarse-grained way to do any kind of port mirroring in any scenario, right? Another issue with a standard switch is that if you were to take two VMs that are monitoring the traffic, if one VM is monitoring the traffic of another VM, and you migrate one of those VMs to another ESX server, that capability is no longer available, right? The two VMs on a standard switch must be on the same host. So with port mirroring on a distributed switch, you actually have the benefit of being able to handle both of those situations that are negatives with a standard switch. You get to choose which port or ports that are being monitored, and you can actually choose which port or ports are actually the mirrors. So you can have it one for one, right? So that one peer mirrors the traffic that belongs to another port, or you can have a port that is monitoring multiple ports. And you can have multiple destinations as well, and it can be configured in a way that supports vMotion, where the port mirror does not have to be on the same host as the VM. It really depends on how you configure that. So this is great for setting up troubleshooting. You have network analysis, of course. You have all the justifications for why we want to be able to support this, and also the port mirror itself doesn't need to be another virtual machine. The port mirror can be sitting on your physical network, so that maybe you've set up your physical switch with one of the switch ports configured to be mirroring over to a dedicated switch port. So if that's the case, you can then in fact have your port mirror traffic routed out of the virtual switch onto the physical switch to a mirrored port configuration there. So in order to support all this, we've got support for things called switch port analyzer, which then leverages remote span, right? Remote switch port analyzer, RSPAN, which basically implements the ability to have the traffic redirected out of the virtual switch, mirrored out of the virtual switch, and then set up onto an actual port mirror on your physical network. There's also support for encapsulated remote switch port analyzer, ERSPAN. This is where, in this case, the port mirror is not on the same local LAN that your ESX server is on, but instead is actually on another network routed away. So there's several ways to implement port mirroring in vSphere, right? And some of those allow us to do this and support vMotion. However, not all of them support vMotion, but every single method that you have available with port mirroring does allow you to pick and choose which port or ports are going to be the ports that we're paying attention to and how we're going to mirror this to some destination. In our example here on our slide, we're seeing the typical what we call distributed port mirroring, right? That basically means that our source port here in the middle is being mirrored over to some other port that happens to belong to a virtual machine. So you can specify the direction of the traffic that's being mirrored, right? So for instance, here our source port, we can look at ingress traffic, right? Going to the port, from the VM to the port, or from another VM to the port, or from the physical network into the port. So we're looking at inbound from the port's perspective. We can also look at egress as the traffic leaves the port, as it leaves to the VM, or if it leaves the port to another VM, or if it leaves the port to the physical network. We can specify which direction we're going to be providing the port mirroring information, and then specify the destination. In this case, it's being sent over to another virtual machine. And you can also specify whether or not is that virtual machine that's capturing all this traffic, which is potentially quite sensitive, right? How are we going to be able to get that information out of that VM? Is that VM going to be able to communicate with regular traffic to the rest of your network, or is it not, right? Notice in this example, we've got the indicator here that the VM over here on the right is getting just mirror traffic. There's no normal traffic going to this virtual machine. So that basically means in order for me to capture any data off of this VM, I'm going to have to open up a console into that VM. You can specify that when you set up your port mirror session. So how do you do this? On your distributed switch, you go to your configure tab, go to port mirroring, and select a new port mirroring session, where you're going to first specify what type of port mirroring session are we going to configure. Distributed port mirroring is the case where both the source and the destination are both virtual machines. This allows us to set port mirroring and get the granularity. This is the one session type, though, that does not support vMotion. When there are these two VMs like this, where it's one for one, the two VMs do need to be on the same host in this particular case. But for the other cases here, remote mirroring source, remote mirroring destination, encapsulated remote mirroring source, all of those, the VM can migrate. The VM being monitored can be migrated off of the host, and it can still be having its traffic captured because of the way how this has been set up. Remote mirroring source is basically the remote span, where the actual port mirroring location is on the local network. So you basically are sending all the traffic out of a physical uplink to a designated port on your physical switch that's then being mirrored. Remote mirroring destination is where you basically are gathering all the traffic that belongs to a single VLAN, and that can be sent either to an uplink or to an actual distributed port. This also supports vMotion. And then encapsulated remote mirroring source, which basically says you're going to need to provide a destination IP address of where the port mirror is located in that case. So now this is going through a router to a destination. But again, if the VM migrates to another host, we're still going to follow the VM and have its traffic mirrored out of the ISIC server and onto your network through a router. But taking a look at the first example here, we're going to go ahead and create a distributed port mirroring session, which then allows you to set what source VM and what destination VM is going to be part of this configuration. Now, the properties page does allow you to specify, first of all, is the port mirroring session enabled or disabled, which is cool because you can set the configuration up and then only enable it when you need it and disable it when you don't need it. And then specify the other attributes. For instance, should the destination have normal I/O capabilities, right? So that goes back to whether or not is the VM that's capturing the data going to be accessible on the network or not. If it's not, then the only way you're going to get this captured data is by opening up a more secure console to the VM. If it's allowed, well, then I can actually potentially, remote into that VM and get the data through your standard network. So in setting up the source and destination, here we show an example where we can define our traffic direction from our source port, right? Both ingress and egress from the port's perspective, and specify whether or not that traffic is being mirrored over to another port, that's distributed port mirroring, or to some other node on the local network. Maybe we can dedicate a dedicated uplink for this mirrored traffic to go to a switch port that's on your physical switch that has now been configured to then have its traffic mirrored to a dedicated port for your network analyzer that's sitting on your physical network. So in our lab exercise, we're going to have you take a look at this capability. And on our ESX servers, we've got two Linux hosts, Linux 1 and Linux 2. They're going to both be on the same port group here. And we're going to simply allow one to be the source and the other one to be the destination. Normally, we wouldn't be able to see private traffic, right? One VM is going to basically ping its default router. That should be a private connection, normally between one node, right? Unicast traffic shouldn't be exposed in a normal switching configuration. But because we're enabling for the port mirror, the other Linux VM is going to be running TCP dump, and you should be able to see the traffic while the port mirroring session has been opened. And then to remove this mirrored configuration, one way to do this would be to manually tear it all down. But because we made a backup in lab number 3 of your distributed switch before having port mirroring configured, we're going to do a restore and have the port mirror session be removed by simply doing a restore from our known good backup that we made in lab number 3. So that concludes our lesson. We just described how to use NetFlow for monitoring network security analysis, and we also configured port mirroring on our distributed switch. This also concludes our module, where we took a look at distributed switches. We saw that distributed switches provide functions that are similar to standard switches, but they also allow us to set up a far greater scalability and centralized way to manage our network. We took a look at Network Out Control version 3, how it allocates network bandwidth to each type of traffic type, utilizing resource allocation settings, such as shares, reservations, and limits. We saw that distributed switch and distributed port group configurations can be backed up and restored, and that distributed switches support the use of network analysis and troubleshooting tools, specifically NetFlow and port mirroring. And we also saw in vSphere 7 a new feature was added to access distributed switch and NSX distributed switch information all in the same vSphere client. So that concludes our entire module. It has been a pleasure. I'll see you again in the next module coming up after a break.